Welcome to my channel. This is part one of a series of videos I'm going to do on building a Treadwell droid. My goal is to make a video for each section of the bot. I'm going to do a head, the body, the mast, the arms. I'm not actually sure how many videos it will ultimately be, but it'll be a process. It'll be a journey. I have already built a Treadwell that matches the A New Hope droid. This droid is articulated. Its head moves up and down, it looks left and right, it moves around on its treads, and it's completely remote controlled. For this build, it will be slightly different. I'm not going to match the A New Hope droid, or remake the one I've already done. My plan is to make one that's a little bit different. So I'm going to change the color, I'm going to probably put on different arms. I may make some of the arms articulated, and I'm definitely going to add additional details. But it will be, a completely different droid. So my two Treadwells can live together in this universe. To kick things off, I'm building the head and neck in this video. I will include plans where appropriate. I will include links to the 3D printed parts. I will include as much as I can in case someone out there besides me really wants to build a Treadwell. So let's get started. I would like to start the project by kind of explaining what we need. Here are all the parts that we need for Treadwell's head. There's some additional parts that you also need for the neck, but right now let's just talk about the head. This part right here is the Treadwell's eye, or the front lens for both eye stalks. And this part is a found part. It's a part out of a Paterson Trident Viewer. And the Paterson Trident Viewer is this thing here. It is meant to show one slide. Works just by pressing the slide into the viewer, and it lights up, and you can see it. Inside this viewer is an internal lens that we used for Treadwell's head. So this was a found part back in the 70s. There were probably a bunch of these types of viewers. The viewer itself was used for one of the Death Star props, one of the cameras, and the internal lens was used for Treadwell's eye or eyes. You will need two to complete a Treadwell. Or you can 3D print the eye fronts or the eye lenses. You have all of the parts available to you on rebeldroids.com, which allows you to print everything you need. You will, however, need to pour the lens with resin rather than print it. You can print it, but then go back and make a mold of it and pour it in resin. The other 3D part that you're going to need is going to be this next piece. You have an aluminum rod that fits into this hole, and it connects to this part right here, which will ultimately support the two larger sections of the eyes. This part right here is to hold the servo. So we're going to need something to attach the servo to. So all of these parts are going to be available on Thingiverse. So the link will be in the description as well. The eye fits into this 3D printed part, or the lens fits into this 3D printed part. I'm just showing these things right now. I'm going to go through the whole process of building everything up to this point, but I just wanted you to see exactly where we're going to be getting to before we assemble the entire thing. This rear part also gives you the exact dimension that you actually need. Additionally, you're going to need I'm using 1/8 inch plywood for all of the construction of the eye stalk. I suppose you could print this. I'm going to release plans for the eyes and for the eye stalks themselves, so that you know where all the holes need to go, you know where all the what all the dimensions are. So yeah, you have 4 pieces basically of the same part. The bottom 2 are going to have holes in them, obviously, that line up, and then the top parts here are going to be solid, so they can be the top. If you're looking at the sides here, you'll notice the bottom side of it, where the eye is wider than the back part, and then those 2 angles need to be drawn in as best you can. I will also include the dimensions of placement of all of the additional holes in this. The blocks in here that are used for screw holes to attach the bottom or attach the top to the bottom are not that important. They just need to line up with the screw holes. Now, what's important about Treadwell's head is that the center is about 3/4 of an inch apart, and they should be parallel with each other. The outer sides of the head are the part that are tapered. So you're going to have a 90-degree angle from the eye to the inner part, 90-degree angle to the top part, and then the outer angle is an undisclosed angle. I'm not sure what that is. I'll give you all the measurements, and then you can cut your pieces from that. Because I'm using wood, we're going to be using a little bit of styrene to skin it. You can also use something like Bondo, and you could coat everything with Bondo and then sand it all down, make it all nice and smooth and flat. But I just went one step further, just cut all of the pieces in styrene, and I'm going to skin the whole thing in styrene. As promised, we're going to show you how we glued everything up. Basically, I'm not going to describe everything here. I'm just going to kind of explain what overview of what I did. Essentially, I'm using the 3D printed parts as a guide so that all of the parts were lined up based on the 3D printed parts, the front and the back of it. We are actually working on the bottom of the what's going to make up the bottom platform of the eye stock here, because I wanted to make sure that the little parts that will become the blocks the screws will go into were well glued to the sides. So basically getting everything lined up and gluing everything down. I'm using wood glue for all of the wood parts. I'm using a silicone glue for any part that is plastic and wood. It's important to remember, don't glue that bottom part to the rest of the enclosure. Okay, once all the dimensions were transferred onto the wood, basically the holes, the placement of where the servo mount's going to go, I went ahead and taped like things like the servo mount in place and drilled holes so that the two parts could be screwed together. I also drilled out the openings so that it allowed me to cut the openings of the of those parts. I used a file to clean up the edges of it, make sure everything fit together properly. And then, same as the servo mount, I did the exact same thing with basically the neck pivot point. At this point, it's super important that you get those two, that center area parallel. Drilled holes, applied screws. Then it's time to attach the neck piece, which was ramming this aluminum tubing through the holes. I didn't go all the way through just because I'm gonna have to take it out, paint it, and I have more sanding to do and such. Basically, once I had all the parts in, is when I went back and measured and figured out what all of the openings were, how much space I needed, and those are going to be in the dimensions of the final parts. So we're going to have all of those dimensions in you. So when you look at the files, you'll see that. And again, you could 3D print this as well. That stock would be a big print. It's not necessary to print this. Like I said, it's super easy to build in wood, but you can also build it in plastic. You can build it, in thicker styrene. I think that also would work very, very well. Drilling the holes for the bottom piece to go into those wood blocks that we talked about earlier. Now, this final piece that needs to come out is for the servo. In this particular build, there is going to be one servo that is fit right inside the box, and it's going to move the entire head up and down. Finally, getting around to skinning the entire box with styrene. So I just used a really thin gauge styrene, some silicone glue, spread the silicone glue all over the wood, and then just laid the styrene right into it. All the 3D printed parts are ABS, so they all needed to be sanded, get rid of those grooves, those build lines and layer lines. So went through and just gave everything a good filing, good sanding, and made sure everything was as smooth as possible. I went in with a little bit of spot putty, and the spot putty is used to just fill little holes and little cracks, little things that are in imperfections, perhaps. You know, some of the thicker layer lines, that kind of thing. Sanded that down and then applied a primer. Light sanding after that, and it was a whole process of primer, sanding, rinse and repeat. Once the styrene or the glue had cured under the styrene, I sanded down all of the edges of the styrene. The styrene itself was a little bigger than the original part, so I went through and I just sanded that down. I did the same thing with the spot putty and just filled the little cracks and holes and things like that with spot putty, and did the same thing. Did primer and sand and primer and applied a little more putty and sanded and more primer. I did this several times just to make sure everything was as smooth as I wanted it to be. I really wanted it to be kind of a metal surface, and so I wanted this styrene to look as real as possible. Added black for the interior of the box, and then more primer. These are the eyes. So these parts needed to be cut off. The Dremel made quick work of it. I used a cutoff wheel to kind of section off the part that I didn't need, and then I used a sanding wheel to smooth out the inner ring. Taped everything up, and then added paint. My final color was Citadel Death Guard Green in spray paint. And I mounted the eyes with some slotted screws. I tapped the holes just so that the screws would hold the eyes in. Now onto the final assembly. Basically, we have all the parts painted. Everything's been sanded and fully finished. Now it's just a matter of getting all the holes have been drilled, all the screws have been fitted to everything, and now we're just simply getting the parts to go together. So it doesn't really matter where you start here. I wanted to build the bottom of the headstocks first, create this platform for everything else to be attached. So the stocks, bottom plates of the stocks went on first, just so that the eyes would be in the right place. Now mounting the servo. The servo was actually mounted to the block first, and then the block was mounted to the bottom of the plate. Each lens fitted into the corresponding eye stock. The lens press fits in, and then there are two slotted screws that help hold that in. You could glue them in, but the original Treadwell had these nice slotted screws that were right dead center of the lens. Test fitting the case. Have to remove the servo horn to get that case to fit in properly. Just this first time, I was still fitting and fidgeting with the opening. Four screws hold the basically the top of the eye stalk into or onto that plate. With the other side, we're going to rinse and repeat. This small 3D printed part is what's going to hold the aluminum tubing around or form the bottom of the neck. So this part's going to be attached right to the center of the neck area where the aluminum mast will be attached. And basically everything gets screwed together. So there's a part that's attached at the bottom, which is a hub, which will fit the shaft that's ultimately going to turn the neck. Then there is the screws that go through the top of it and go into that 3D printed part. All of the exposed screws are slotted screws, just because typically that was the screw that was used in the 70s. So we really needed to make sure that we had the right screws. Here, I forgot to add the space or the hole for the wire for the servo to go, or the power to go up to the servo. So I'm doing that for both on the bottom of the basically the plate for the eye stock, and then also the bottom of the neck piece. This is just allows for the wire to pass through. Here's all the aluminum parts that will form the top of the neck. The aluminum parts are also screwed together, or there's a hole in them for the screws to attach and ultimately keep everything in place and in position. The black part is a painted aluminum piece. On the original Treadwell, that black part was the slip ring. Assembling the neck now. I'm basically using a bunch of found motor mounts for a small planetary gear motor. And the reason I'm using these motor mounts is I need to connect two shafts together, one from the motor and then one going up to the very base of the neck. And I want that collar to be real strong, and I want it to spin freely, and it's all got to be within the aluminum tubing. So the motor mounts seemed to be the best choice. They were super easy to use. They were, all the holes lined up, so that was nice. And basically, they were all found parts sitting around in my garage, so I used those. The motor mounts are trapping this aluminum sleeve, and this aluminum sleeve fits within the other outer aluminum pipe, which you'll see here shortly. This was a bit fidgety, as you need to make sure that that aluminum pipe is centered so that the motor and everything can slide down into another aluminum pipe. The mast is basically a series of aluminum pipes. I'm going to do that in a different video, but I wanted to make sure that the neck was prepped and was really done based on that pipe. So I have the parts of the neck that I'm going to be, or parts of the mast that I will be using, and they're going to, and so I use them to make sure that all these parts fit together. Once all the shafting and everything was all tightened down onto the hubs and such, the aluminum shroud or parts that are making up the outer aluminum can be attached. And basically they're just attached to the neck part. So the motor is going to move all of the aluminum and the neck and the head and everything all together from down inside of the mast. The only thing that's going to pass up through past the motor is a wire that feeds power to the servo and receiver that will be located inside the eye stock. Of course, I had to take it all apart because it was really tough to try to work this aluminum pipe through the actual neck part and into the those lower hanging parts of the eye stalks. This just made it easier for me to work on the whole thing. So I just pulled the 4 screws from the top and just removed the neck from there. In the middle between the two necks parts are 2 shaft collars. They're just 2 regular shaft collars that fit that aluminum pipe perfectly, and they just are tightened with a set screw. The way I'm building this head is exactly the way the original Treadwell head was made. The Treadwell I made, my original Treadwell, actually used 2 servos that allowed the eye stalks to move up and down along the from that center point. But this particular Treadwell and the original Treadwell used a arm, if you will, a lever that attached to the base of the neck and allowed the servo to push up and down on the eyes. The motor and everything fits just down into the aluminum shaft. This is an ABS pipe though, just to hold this thing together for right now. And I'm just putting out a few little parts here just so I can test the mechanics on the eyes. So I just wanted a really simple, like most of the stuff's going to go on Treadwell down in the body, but I don't have the body yet. I haven't built that yet. So that's coming as another video. And I added an on-off switch just so I could test everything out. Power wires run up through the neck and up into the head that connect to the receiver, and then ultimately the servo connects to the receiver. Don't mind all my wire nuts. I ended up actually soldering everything together, just didn't show it. And the base of the motor wires are connected directly to the speed controller. And on the base, in between the speed controller and the power distribution board, is another receiver, the same receiver that's up in the eye stalk. So both receivers are getting a signal from the transmitter, which allows it to move the neck left to right, and then ultimately move the head up and down so that it can look up and look down. Of course, I had to take everything apart just to make sure I could get everything, all the electronics in there properly and wire this up properly. And again, most of this wiring is just for me to test it. I really didn't want to do something that was super elaborate. It's not something that's super finished. The only thing that's finished is the servo in the head with the receiver in the head. And basically you can see right in the center there, the arm that's attached to the neck, and that's attached to the edge of the servo horn, and it allows the servo to lift up on the very front of the face, or front of the eyes. The head left to right side motion is controlled by that motor and the speed controller. Thank you so much for watching. I hope you enjoyed this video. Again, this is part 1 of the Treadwell series that I'm going to do on the full build that is a Treadwell droid.